TOA was sine theta equals opposite over hypotenuse. If you want to write it because you feel the need, go ahead. Okay. Cos theta equals adjacent over hypotenuse. And tan theta equals TOA, so it's opposite over adjacent. Now, you can see those three, correct? The catch is we're now doing all on a unit circle. They're not just a triangle that can be flipped, twisted, and turned. Remember? So when we did triangles in grade 10, you would have a triangle that could be turned, and you could use different angles, right? So if I used the angle at the bottom, don't draw this, I'm going to erase it. If you used the angle at the bottom, this was your opposite, this was your adjacent, but this was always your hypotenuse across from your 90, correct? Then if we use this angle, this was my opposite, this was my adjacent, this is still my hypotenuse. So your opposite and adjacent move depending on what the heck angle you were using, correct? Now people think grade 12 trig is harder. It's actually not, because your triangle will always sit in one spot on your unit circle. It doesn't move. So if I were to look at my unit circle, let's look at the 30. So the 30 degrees would be here, correct? Your unit circle would do something like that. You have a triangle like this. And that's straight down. So this is always your angle. You see that? So is your rotating circular angle, right? 30 degrees, you know that. So your angle never changes. That's the great thing. Your opposite and your adjacent never change then either. So this would be my opposite, and this would technically be my adjacent. Is that correct? See how I'm trying to change my picture? Yeah, it is correct. Now, this is a Cartesian plane, your x and your y. What is this? X or y? This is y. What is this? X. So on the unit circle, your adjacent is always your x, and your opposite is always your y. You see that? So instead of saying sine theta equals opposite over hypotenuse, we're now going to say y over x. And instead of adjacent over hypotenuse, we're going to say x over, our hypotenuse is what? What is this thing that spins around in a circle? What's this line from center to edge? Radius. So all of our hypotenuses turn to radius. Opposite, y, adjacent, x. Why is this one an x? I don't know. I'm an idiot. Let me write this in. All right. Got it. Already said it. Almost faltered me, but I got it. Winner, chicken dinner. All right. So hypotenuse is always turned to radius. Hypotenuse. Hypotenuses. I don't think it's the same. Like hypotenuses. Okay. Hypotenuse is always r because it's my radius. It's from center to edge. Correct? And then adjacents will always be x's because no matter where I draw my triangle, it's still going to be my adjacent, still going to be my x. Still going to be my adjacent, still going to be my x. You see, because we always do bow ties, there's always the x's. So your adjacent is always x. Now, if you want some fun acronyms, here they are. Sign your resume, which I don't actually think you do. I think you sign your reference letter, but that's fine. Or you sign your formulated letter, but fine. These were chosen like 10 years ago. I remember what kid it was. He's now going into engineering, and I think he graduated in 10 years ago. But so you can change your mind as to what you did in life. Yeah. All you people who are stressed out about being 18, choosing what you're going to do for the rest of your life. For 10 years, you can pick something different. Most people actually don't become what they went to university for, just so you know. I went to university. Okay, pick extra rice. I get that extra starts with an E. We didn't care at the time. You can care. Pick up something else. And then this is tan your Xbox, because who doesn't want to tan their Xbox? Someone else said last semester, or a year ago, I don't remember, text your X. But I think you should do that. So whatever, you can use what you want. whatever makes you remember X also doesn't start with an X, but it works for that person. So if you want to do that, you go ahead. So for points on the unit circle, R equals 1. Therefore, the primary trig ratios on the unit circle can be expressed as, this is why it's Calgary Stampede. So sine is y over radius, correct? So the unit circle's radius is 1, correct? So y on the unit circle is cos of that value. I didn't sign that value. X is x over radius is 1. So that's why all the x values on the unit circle, okay, x on the unit circle are all the cos values. Then if I want tan, I'm going to do y divided by x. All right? Go to the unit circle for a second. Now, the inside of your unit circle are the angles, correct? There are the degrees and the radians on the inside. The outside are answers. The outsides are coordinates. The outside actually gives you answers to cos of 30, sine of 30, tan of 30. Let's try that. So I want you to go to 30 degrees. Maybe a little clearer. Cos of 30 is the x. Remember, it's just x over radius. Radius is 1. So what's your x at 30? Square root 3 over 2. So if I had actually asked you, I'm not doing this, I'm just putting a point. Cos of 30 degrees, your answer would be root 3 over 2, technically over 1. Which is why it's just root 3 over 2. Because it's x over r. Okay? Sine is sine your resume. So it's y over 1. What is y? 1/2. What's 1/2 over 1? 1/2. So that's why I said Calgary Stampede or Crystal Stupendous or whatever you want to do, because it's, I know, Crystal is so awesome. That would be an A. We'll pretend it's one word. So awesome. Superior. Crystal is superior. Anyways, that's how you get your x and your y. You don't even need to memorize it if you know that cos is x over r and sine is y over r, right? Now tan is y over x because it's tan your x box. So if I do tan theta, it's y over x. If I do tan of 30 degrees, the only thing that should ever go in for theta is degrees or radians, right? It's an angle. Theta is an angle. Angles mean degrees or radians. So this would be y divided by x. What's y? 1/2 divided by, the moment I do a fraction, I never, ever, ever, ever stack fractions. So I'm going to do 1/2 divided by x, 3 over 2. What do I do when I divide by a fraction? Yeah. Multiply by the reciprocal. So we're going to get 1 over root 3. Then we're going to bring back grade 11 all the time. Grade 11 is usually a lot. Grade 11 radicals. So how do we get rid of root 3 in the denominator? How do we rationalize the denominator? Multiply by root 3. Because when you multiply by the root that's the same, you get the same answer. Because root 3 times root 3 is root 9, which is 3. Right? Root smiley face times root smiley face is just smiley face. Thanks for all the answers. So, off our unit circle, we can quickly get cosine and tan. Now, we don't stop there because we have secondary trig ratios in 30-1. What are your formula sheet? There's something really like hardcore on the grade 1. I double that one. Enjoy. top of your formula sheet. Look at it. There's tan, which is sine over cos. Sine is what? Y and cos is x off your unit circle. But then there's also these other ones. Cosecant, secant, and cotan. Do you see them? Now, the way that I always remember them is C never goes with C, and S never goes with S. So cosecant goes with sine, and secant goes with cos. Like cosecant doesn't go with cos, they use CC. It doesn't happen. Also, you don't have to memorize it. It's on your formula sheet in front of your face. You guys forget that all the time. People will pick the wrong one. I'm like, how do you even do that? It's on your formula sheet. Your formula sheet shows which goes with which, correct? You're given so few things in life, use your formula sheet, all right? So if it's 1 over sine, sine is sine your resume, it will be 1 divided by y over r. Well, we never stack fractions, so it will be 1 divided by y over r, which is 1 times r over y. That's why cosecant is just r over y. They're called secondary trig ratios or reciprocal trig identities. What does reciprocal mean? Starts with an F, rhymes with crip, rhymes with clip. Yeah, it is flip. Reciprocal just means to flip. It means to invert, but flip works better. Are you? Yeah. Okay. I'm done if that's the case. I'm like, you're not going to get it. All right. So, if cosecant is a secondary trig ratio and it's the reciprocal of sine, if sine is sine your resume, and cosecant is resume your, which is stupid, but you'll start saying it. Don't worry. And then secant is opposite of cos. Cos is cooked extra rice. So this would be rice extra. And then tan is tan your x box, so this is x box your. And you're like, wow, those are stupid. Yep, and you'll be saying them stupidly in like 3 days. So can I get those answers off the unit circle easily? Yeah. They're just the 3 answers I had put. Right, we're just looking at them. So, sine 30 is a half. Cosecant is Bessie. Is what? What's a half flip? Yep. You will learn to like the halves. They turn to 2s. And you don't have to rationalize. Okay, cos is root 3 over 2. Cos is Bessie is secant. So remember, C's and S's don't go together, or C's and C's don't go together. So secant of 30 is the flippy flip of root 3 over 2. So what is that? 2 over root 3. How do I rationalize that? I'll put my root 3. So I get 2 root 3 over 3. If I have to find cotan, I don't go find tan first. Because tan is you having to divide 2 things, correct? So if cotan is dividing 2 things, why would I find tan first, then flip it? I can just go straight to cotan. On your formula sheet, what does cotan say? Not the 1 over tan one. What does cotan say? Look at your formula sheet. I need to know where stuff is. Not me, because I'm not writing your test. You are. Cos over sine. So this is the same as cos of 30 divided by sine of 30. What is cos of 30 on your unit circle? Calgary, Stampede. It's the what? The x. What's the x on your unit circle at 30? Root 3 over 2. What's sine of 30? 1/2. What's root 3 over 2 times 2 over 1? The 2's cancel, that's just root 3. grab out a separate piece of paper. We're practicing a few things because I lose people when I actually teach it the actual way. So we're going to do a little caveat on that. You try these ones out, remembering that cos is the x and sine is the y on your unit circle. Yep. Yep. So, sine 120, remember calculus delta or crystal stupendous, whatever way you want to remember it. So sine is just the y on the unit circle, correct? Remember, cos and sine, if I ever ask you for cos and sine, you should literally want to do a cartwheel in the hallway because they're literally just answers off your unit circle. Poof, poof. If I ask you for cos of an angle x, sine of an angle y, like you should be like throwing a little party in your head. You can invite everyone else's head because those should be the easiest ones to do, right? Worst one's done, but it should be the easiest thing. Go to cos, pull it off, the x, sine, pull off the y, okay? Sine at 120 is what? Square root 3 over 2. Right, Lord. Because it's just the y at 120. Cos at 120 is just the x. Boom. Easiest things ever. It would be negative. It's in quadrant 2. Cosecant is sine flip. That's why I wrote it across from it. So you shouldn't need a lot of brain matter. You just flip it. 2 over root 3. Then I just need to rationalize. If you're someone who's like, Mrs. Lepp, what is rationalizing? What are you doing right now? I have no idea. That is a hint to come in at lunch or nighttime. That is a grade 11 outcome that I don't have time to completely reach perfectly. But if you pop in, I can show you how to do it. Okay? So if you're lost as to why multiplied by root 3, come in and ask. Secant. If it's negative a half, my secant is negative 2 over 1. Flipping does not mean changing signs. Flipping means flipping. Like you just flip. That's the definition of flip. Okay? Which is just negative 2. If you left it, people are like, what if I leave it at negative 2 over 1? It's still the same thing. You're great. Check mark, right? The multiple choice will only show negative 2. Tan and cotan are where the work happens. Tan is sine divided by cos. It says it on your formula sheet. Like you don't have to memorize it. It's literally there. Sine is my this. Divided by cos is this. And I math. So I get root 3 over 2 times 2 over negative 1. And I get negative root 3. Cotan. If you want to, you can literally write it out the way the formula is on your formula sheet, right? Cotan theta equals cos theta over sine theta. Well, it's not theta, it's 120. So cotan 120 is cos 120 divided by sine of 120. Like it's off your formula sheet. Use your formula sheet. Even in plastic, like it's begging for you to use it. Okay? You don't memorize and get it wrong. It's right there. Cos of 120 is negative a half. I never stack fractions, so I'm going to write it sideways. Sine of 120 is root 3 over 2. So it's negative a half times 2 over root 3. The 2's cancel. I'm left with negative 1 over root 3. Multiplied by root 3. Multiplied by root 3. And I get negative root 3. Root 3 times root 3 is 3. That is root 9. Kind of making a little more sense? Cool, because we're going to be doing coterminal angles with this as well, and radians. So we're going to practice another one. Remember, if you ran out of paper, I have paper at the back. There's no reason to not be writing out these. Okay. Next one I'm going to ask you to do. 7 pi over 6, because who wouldn't want to do that? So sine 7 pi over 6. What's sine's bestie? If you don't remember, look on your formula sheet. What goes with sine? Co, C, can't. If not, say CSC if you don't remember the words. Then I'm going to want you to do cos. That's 7 pi over 6. What's cos's bestie? Theta. These should never be backwards. You should never put cosecant with cos and secant with sine. It's on your formula sheet, right? That means you're not looking on your formula sheet. You should never get them mixed up. They're on your formula sheet. I don't know if I'm drilling home that you should look at your formula sheet enough, but your formula sheet is very important. And your formula sheet should be out for the rest of the entirety of trig. Formula sheet. Look at your formula sheet. Formula sheet. Some people are like, but Mrs. Lepp, I couldn't remember it. I'm like, formula sheet. So I'm going to keep saying that over and over and over. You know where you can find tan and cotan as well? Formula sheet. Crazy. Try these 3 out. So 7 pi over 6. I go to 7 pi over 6. 7 pi over 6 is sitting right here. Okay. Its coordinate is negative root 3 over 2 and negative a half. Okay, I'm just going to insert that, right? Y is negative a half. X is negative root 3 over 2. This is negative 2 over 1. This is negative 2 over root 3. If I don't change signs, I just flip. The besties are just flips of each other. Tan is y over x. So it's negative a half divided by negative root 3 over 2, which is negative a half times negative 2 over root 3. Cancel the 2's off right away. It doesn't make your life easier. Negative times a negative is positive. And then rationalize. Now this one is cos 7 pi over 6 divided by sine 7 pi over 6. Cos of 7 pi over 6, negative root 3 over 2, divided by sine of 7 pi over 6, negative a half. So I get negative root 3 over 2 times negative 2 over 1, which is root 3. Now we're going back to our numbers. We're going to go a little unorthodox. We're going to move ahead in our notes. So we're bypassing this. That's what we're learning tomorrow. We're going here. Determine the exact value in trig means I'm going to need my unit circle. Because exact value is not decimals. And what's on your unit circle on the outside? Not decimals. Exact values, right? So now I'm not asking you for all 6 trig ratios of every single one, right? Because that's rare that would ever happen. I just was proving a point that if you get cos, secant flipped. If you get sine, cosecant is just that flipped. Tan is sine divided by cos. Cotan is cos divided by sine. I was just showing you that that's how you can get all 6 of them, right? Tan, pi over 2. What will we do? Go to our formula sheet. Because we like our formula sheet. Formula sheet's best friend. Okay? Our unit circle gives us cos and sine. Feel like I'm cheerleading. Okay? Our unit circle gives us cos and sine. Our formula sheet gives us cos and sine. Why wouldn't we use it? So, tan is what over what with coses and sines? So don't answer it once. Tan is what with coses and sines? Sine over cos. So I'm going to write it as sine pi over 2 divided by cos pi over 2. Because what does our unit circle give us? Sine and cos. Yes? What is, yes. Thank you. Thank you. What is sine at pi over 2? Remember Calgary Stampede. Cos is x. Sine is what? What did you get, Kate? 1. What is cos there? Can we divide by a 0? Or is that illegal math of all the illegal math? Illegal math. So we write undefined. You're actually going to see there'll be an asymptote there when we start doing graphs, which is the next unit. Is cosecant on our unit circle? No. Is there a formula on your formula sheet? Yeah. What is cosecant on your formula sheet? 1 divided by sine of 7 pi over 6. Is it not? Could I just take the sine and flip it and memorize that? Yep. Could I just use the formula on my formula sheet just in front of my face? Yep. So let's do that. We get 1 divided by what's sine at 7 pi over 6? We just did this one. Negative 1/2. So it's going to be 1 times negative 2 over 1, which is negative 2. Do you see how I can use the formulas on my formula sheet? Because the formulas on my formula sheet all have coses and sines. What does my unit circle give me? Cos and sine. Okay, sine of negative 300. Whoa, whoa, whoa. Slow your roll. That is not on the unit circle. But it actually is. How can I get it to be on the unit circle? How do I go the other way? Move the thing the other way. So you can move your little spinner the other way. Or what can we do? Yeah. Take the coterminal of it. How do I get that? I don't know why I'm acting like I'm like someone's gonna shoot me or something. Plus 360. Yes. So negative 300 plus 360 is 60, which you guys like better, even though I like negative 300. It's cool too. Those are equal, are they not? Now go to sine. I'm going to go to 60. Give me sine. What do we get? What happens? I was stuck in my room for a second. Not special. And 3 over 2. It's 0. Oh, secant. How we don't like you because you're not sine or cos. That's what you normally say. But then you say, no, we like you too. We go to our formula sheet and we look for secant. Secant is what? 1 divided by cos. So 1 divided by cos of 60. We don't stack fractions, so we're going to write as 1 divided by, what is cos of 60? 1/2. So it's going to be 1 times 2 over 1. And what do we get? 2. Voila. Oh, look at these. These are nice. I might want you to do them. Try out EFGH. So cos of 150. We go to 150 and you give me the what? Calgary Stampede. You give me the x. And what is the x at 150? Negative 3 over 2. Sine 315. You give me the y. What is the y? Negative 2 over 2. Sine negative 30. You can literally rotate with your, that's why I gave you one of these with an arrow, right? Sine negative 30, you could rotate it down here and just look. Or if you're like, I hate that, so add 360 to it. And it's the same as sine 330. Same spot, though, right? Like, and then sine at 330 is negative 1/2. Tan 240, go to our formula sheet, and we do sine 240 divided by cos 240. Sine at 240 is, what do we get? Negative 3 over 2. Cos at 240 is negative 1/2. Negative 3 over 2 times negative 2 over 1. And we get 3. 480 is a lovely number. What is it? Correct? So could we go 360 and then keep going with our little spinner? Yes. Or we can subtract 360 from it. And what do we get? Tan 120. It's the same answer. It's coterminal. Coterminal lines in the same arm. That's why you're taught coterminal angles. Right? For this very moment. So tan of 120. I don't know where we're in here. Tan 120 is sine 120 divided by cos 120, because that is what the formula sheet tells me. And I am not a rebel. I'm going to use the formula sheet. Sine at 120 is root 3 over 2. Cos at 120, 1/2. Yeah. So I'm going to get root 3 over 2, negative 1/2, right? Times negative 2 over 1, the 2's cancel, and I'm left with negative root 3. What happens when I have a squared? Squared just means try the whole thing and square it. This is the exact same as writing cos 225 degrees squared. So what is cos at 225? Negative 2 over 2. Let me see what that is. Okay, when I square a root, if this is confusing, which is to some people, whenever you get a square, I told you you can cross it off and rewrite it twice. A lot of times that's easier for people, so go ahead and do that. Root 2 over 2 times root 2 over 2. What's root 2 times root 2? And what's 2 times 2? And what's 2 divided by 4? Yay. Oh, wow. The result, yeah. True statement. This is true again. Awesome. Okay, this one I want to be secant. This one I want to be cosecant. Yeah, I get to do extra. And then this one, I know, you're welcome. This one I want to be secant. What do you think I want this one to be? Cos. Cotangent. It's just the opposite. You can't just pick the opposite of each one. So I have to do NNOP. And you will be done. After we're done. So secant negative 2 pi over 3. You can look at this two ways. 2 pi over 3 is the same as what? How many degrees? Look on your unit circle. You don't have to convert. 2 pi over 3 is on your unit circle. It's the same as what? 120, right? Now they want to go negative 120. So if I want to go negative 120, I can actually go 90 plus another 30, and it would land me here, and this would give me my answers. Correct? So I could just go negative. I love how I'm explaining this. Whoever's watching this is like, I can see nothing. You're welcome. That's what the positives, the negatives to being broadcast. So I can do that 120, or we can do the coterminal, which we add 2 pi to it. But remember, if you type this in with the pies, no matter how hard you press the mouse enter, no matter how mad you are on a test when I say that doesn't work, it isn't going to get you a fraction. You have to put it in without the pies and add the pi back, right? So if I go negative 2 pi over 3 plus 2 pi, I get what? Secant of, pardon? 4 pi over 3. And it's the same spot as 4 pi over 3 if you reverse it. So I like physically spinning it myself and just finding it, but you can do coterm triangles all you want. Absolutely. So secant of 4 pi over 3 is the same as 1 divided by cos of 4 pi over 3. Or you can just flip cos, but anyway. It'd be 1 divided by what? Negative 1 over 2. Which is 1 times negative 2 over 1, which is negative 2. Cosecant of negative pi, you can literally take your arrow and negative pi. Cool thing about negative pi, same as pi. Boom, right here, right here. And why is it the same as pi? Because if I add 2 pi to negative pi, I get up. Cosecant is 1 divided by sine of pi. What is sine at pi? What is y at pi? 0. What happens when you divide by 0? I'm just fine. Can't divide by 0. It's illegal in all states, territories, countries, the world, and Mars. Talk to those people. They said. Now, secant negative 5 pi over 3. We could just go negative 5 pi over 3. You get it over here. Or we can add 2 pi to it. And we get secant of pi over 3. Which is the same as 1 divided by cos of pi over 3. Wow, I picked a lot of nice ones. 1 divided by, what's cos of pi over 3? Good answer, guys. Thanks. So helpful. 1 times 2 over 1, which is 2. You probably just feverishly writing the can answer. That's cotan squared of 2 pi over 3 is the same as cotan of 2 pi over 3. Get me the answer to that. Square. Cotan 2 pi over 3 should not be overwhelming because there's a formula on your formula sheet. I think I've said that enough. Cos of divided by a sine. Squared. Cos at 2 pi over 3 is a half. Negative. Divided by sine at 2 pi over 3 is 3 over 2. Square that, baby. Then I get negative a half times 2 over root 3, which is negative 1 over root 3. Now, some people rationalize. You don't have to because we're going to square it. It'll rationalize itself. You rationalize it, totally fine. So I can go negative 1 over root 3 times negative 1 over root 3, which is 1 over 3. Some people got 3 over 9. Fun fact, that is 1 over 3. Reduced. Okay. Now, some people are like, I'm going to do my homework in a week from now. Not helpful in trig. You will be lost because all of the trig, as you can see, builds off each other. I need coterminals to be able to solve for this, right? I need unit circle to be able to solve for this. Everything builds. I'll help you with that. So, your homework is this. I would do it tonight. Page 201, number 1 and 9. Number 1 is just these. There's quite a few of them because you need practice. Number 9 is using those values, but actually adding them together or subtracting them by like a cos pi over 3 plus sine pi over 6. And you put them together. Okay?